Welcome back. We are looking at doing this second half of section 3.2 in Math 95. So far, we have defined relation, domain, range, and function. And we've learned how to identify a function based on its domain and its range. So we are now going to look at the vertical line test, and then finding the domain and range of a function. Once we know something's a function, finding its domain and range. We will also practice with something called function notation. So the vertical line test is a way to graphically, so from a graph, tell if something is a function. This is a way to tell if a relation is a function from its graph. So with the vertical line test, you pass an imaginary vertical line through a relation. If these are my axes, and say that this is my relation. I want to pass an imaginary vertical line through my relation at every single possible input value, so all along the x-axis, so it's sliding clear across. And if that vertical line ever crosses the relation more than once, we cannot have a function. So the question is, will a vertical line ever cross the relation, I guess the relation's graph, more than once? So this is one of those things that best way to get a feel for it is just to try it out. So let's move on to the next slide. We're going to practice just looking at if graphs pass this vertical line test. That will tell us if they're functions, and then we will go and state their domain and their ranges. So I just want to give us a little bit more room to work. If I look at this graph, I am looking to see if a vertical line, let me draw a vertical line that I can use for this. Let's go lines. I just want to we'll do a dashed pink line. Let me see if I can make it vertical. Hang on one second while I do this. So here's my vertical line, alright? So as I drag this, nope, let me lock this in place so it doesn't move. Lock in place. And lock all of these in place so they don't move. I didn't realize they weren't locked. Lock in place. Lock in place. Alright. So if I take my vertical line and I drag it across this graph, will it ever touch that relation more than once? Now the arrows mean that this relation will continue in this same behavior the entire time. It's never going to deviate from that behavior. So this graph never violates the vertical line test. This one passes the vertical line test. So we'll give it a green because it passes. And we like to abbreviate the vertical line test VLT. So it is a function. So now we need to determine its domain and its range. Now remember, the domain was all possible valid input values. So if you think about it, the farthest to the left that I'm going to have inputs will be negative infinity. And the farthest to the right that I could have inputs, this continues going to the right forever, will be positive infinity. So my domain would be every single value between negative infinity and positive infinity. All of them. I will know what's happening at -1 and -2 and everything between -1 and -2. So to show that I know what's happening at every instant between negative infinity and infinity, I have to use a different type of notation. I can't use set notation. So in this case, I have to ask the question, can I ever hit negative infinity? And the answer to that is no. So to demonstrate that I cannot ever reach this value, I put a round bracket, and I'll put a round bracket on either side, because I can't hit positive infinity either. So now let's look at the range of this function. I'm looking at output values, and I want to go most negative to most positive. So my negative output values are going to happen over here. And if this line continues forever in this direction, its smallest output value will also be negative infinity. And the biggest output value, if this goes to the left forever, it's also going to go up forever. So it will hit positive infinity. So my range will be between negative infinity and positive infinity as well. Let's move on to the next graph. I want to take my vertical line again, and I'm going to drag it across this relation, and well, that's pretty boring. It never does anything interesting. So this does not violate the vertical line test. It is also a function. So this also passes the vertical line test. So it is a function. Let's talk about its domain and its range. These arrows again indicate that I will have the same behavior forever. This arrow is pointing to negative infinity, and this arrow is pointing toward positive infinity. This has the same domain as my previous function. Let's take a look at the range. The output values that I have, it's only ever one output value. And I haven't labeled what that output value is, so I have to create a scale on this graph so we know what it is. Let's pretend it's the 4 that it looks like it is. Let's just pretend. So my range value is only ever a 4. And you could put that in the braces, like we said before, because that's the only value it will ever be. Not a very interesting range or domain. Let's take a look at this next graph. So again, remember, the first question I'm looking for is, do we pass the vertical line test? So I take my vertical line, and I bring it next to this egg shape, and I'm not having a problem, then all of a sudden I am. If I drop this vertical line here, I have a problem. I will touch my relation in at more than one place, here and here. And it doesn't matter that it happens throughout the entire shape. It just has to happen one time in order for it to break the function. So this fails the VLT. So it is not a function. But we can still find its domain and range, so let's do it. The domain of this relation is again all possible valid input values. And I want to list them from most negative to most positive. So when I look at my graph, I see that the most negative input I can have is right here, and the most positive input I can have is right here. Just like with this second relation, I first need to put a scale on my graph so I know how big it is. So let's let this be a out of 5. And I probably want to do the same thing for my other graph. It's not like a 5, let's make that a 10. Oh, we'll go easy, we'll call it a 2. And a 2. I was going to be tricky, but I decided not to. So my domain here, I'm going to go -1, 2, 3, 4, 5, 6, -6, on up to, I want to look at this value here, so that's 1, 2, 3, 4, 5, 6, 7. It looks like it hits 7. Now, can it hit 6? It looks like it actually hits 6. So I don't use the round bracket. Instead, I use a square bracket to indicate that I can actually be that value. The round bracket's like a bubble. If I touch the bubble, I burst it. I can't actually touch that infinity. The square bracket's like a wall. I can actually hit that 6 and rest on it. So that's why we use that notation. I can also hit the 7, so I'll get a square bracket on the other side as well. The range of this relation is going to go from the most negative output value, which looks like a -1, 2, 3, 4, 5, 6, a -6, up to a +1, 2, 3. And I'm sort of guesstimating here. I don't care about the fact that it doesn't quite touch that line. We're going to say that it does and just blame it on technology. We'll go -6 to 3, and again I'm going to say that we hit those values and I'll put square brackets on them. So let's practice this a little bit more. I just want to talk about some other types of functions that we might see. So this is a vertical line. Oh, let me go grab my vertical line from that other slide. Hang on 1 second. I want this guy. Let's cut you. Let's actually just copy you. And we will paste it on this slide. So here we go. Here we have it. And let me lock these in place. So if I drag my vertical line, I don't have any relation, have all of my relation all at once. So this totally fails the vertical line test, 100% of the time. So that means it's not a function. We could talk about its domain and range. So its domain is all possible valid input values. This only has a single input value. If I call this 6 here, then my input value here would be 12. My outputs, my range, all possible valid output values. Well, the most negative I'm going to go, according to my graph, the most negative I'm going to go is -infinity, and the most positive I'm going to go is +infinity. So I have one input, infinite outputs, definitely not a function. This second graph, kind of weird looking, I know. Let's see if it's a function. We're going to take our vertical line, sweep it across. At no point does my vertical line touch that relation more than once. So this one passes our vertical line test, which means it's a function. Which makes us happy. So let's look at the domain and range of this function. If I remember my arrows mean I have the same behavior forever, my leftmost input, if I imagine this going on forever, is going to be -infinity. And my rightmost input is going to be +infinity. Let's take a look at the range. You might be tempted to say that the range is going to max out up here at that +4 looking thing, and down here at that -8 looking thing. You might be tempted to say those are the maximum and minimum values, but remember, this arrow means that this is going to continue this behavior forever, and continue this behavior forever. So my range for this function is also going to be -infinity up to infinity. Be careful with things like this, they may try to trick you. One more time, let's take a quick glance for the vertical line test. If I pass my vertical line across this graph, doesn't look like I have any issues. We're going to say that one passes. Green. It is a function. Let's look at our domain and our range. Domain is all possible valid input values. So these are dots, not arrows. These dots mean that my behavior actually stops here. I don't go any farther. So these are our endpoints. Oh, that just looks like an arrow now. I meant to make that look like an endpoint. I stop at that wall, and I stop at that wall. So my domain is definitely a set number of values. I don't go on to infinity. And again, it looks like I hit some values. That's actually what the closed dot means. It means I hit some values. Let's make this a 2 and make this a 2. We'll go in easy scale. So my most negative input value is going to be 1, 2, 3, 4, 5, and -5. And my most positive input value looks like it's a +5, if I read that correctly. If I miscounted, please email me, let me know so that I can fix that. In class, I do that all the time. It's funny. For the range of this, is this my most negative input value? Output value? Output goes with range, not input. Actually, this one is down here. So my range is going to be a -1, 2, 3, 4, 5.5-ish. And we're guessing, and it's okay that we're guessing here. That's all we need to do, just get an idea about it. And then the maximum output value I'm going to have is up here. So it's 1, 2, 3, 4. And I can hit those, so I'm going to give those square brackets. So that's using a graph to determine if something's a function and determining domain and range. Just remember, look for the smallest output, smallest input, biggest output, biggest input. Most positive and most negative. We need to get a little bit more vocabulary and then dealing with some function notation. So I think I might actually split this lecture into a third piece. So go on ahead and practice dealing with domain and range and your function notation, and I will record this in a separate lecture. I'll talk to you soon.